This is Ms. Black. This is Open Campus, College Algebra 102. We are still in Module 11, and now we're on Section B. So we saw in the previous module a new equation, exponential, and we learned the way to solve it. And we learned our definition. We said an exponential equation has your variable in the exponent spot. This module is really lots of fun. In this module, we actually get to do some real-life examples of where you would see an exponential equation and how it relates to you. But in order to do this module, we're going to have to rely heavily on using our calculators. So the first part of today is using our calculators. So please make sure you go get your calculator now to follow along. Okay, let's look at our notes. All right, so we're going to start off with using our calculator. And I want to remind you, when I saw you last in Module 11A, we said for the exponent we have a caret symbol, which looks like that up arrow. So that's what we're going to be working with today, that up arrow. And I want to make sure everybody realizes when you have an exponent, it's connected to a base, and that base and the exponent can be any kind of number. All right. So what I want to do right now is work on these 4 examples. This is just a typing exercise, making sure you know how to use your calculator. So if you look, the directions say we're going to round our answers. And that's because it's not a real-life word problem. We're allowed to cut it off if we're just doing a typing exercise. So let's go up to the whiteboard and let's talk through. So go get your calculator so we can work these out. All right. I want to figure out the values of 2 to the 1 and 4/10. Now, you have to understand something. I'm old, okay? When I was in high school and college, these lovely little $10 calculators were not readily available. I went all the way up through calculus with never using a calculator. Okay? So when I was given something like this, no, I could not get the exact answer, but I was able to estimate. And that's a big deal to me. As your teacher, your instructor, I'm going to say this. Before you ever touch this calculator, would you take a minute and try to estimate what you think the answer is going to be? Because a lot of times you guys type stuff in the calculator, hit equals, write the answer down, and don't even think, does it make sense? And if you type it in wrong, you're going to get the wrong answer. And that's not the calculator's fault, that's your fault. Remember, the calculator is only as smart as the operator. So, when I was in school, you're right, we didn't have calculators to do this. So we had to estimate. And I know 1 and 4/10 is between 2 whole numbers. It's between the number 1 and the number 2. Do you agree with that? So when I was in school, we had to say, okay, this is going to be a little bit bigger than 2 to the 1st, but not as big as 2 squared. Because 1 and 4/10 is between 1 and 2. And then that way, at least I knew what the answer should be. So 2 to the 1st is 2. 2 squared is 4. I know this answer's got to be bigger than 2, less than 4. Now, we're going to use our calculators. So we're going to type this in. Remember, I can't actually show you what's on my screen on my calculator, so I'm going to write it on the board. When you type this in, it's real simple. You write the base, 2. To tell the calculator you're putting an exponent, that's your caret button. I told you the other module, you always put an open parentheses. 1 and 4/10, and close it and equals. So let's type that in. 2 caret parentheses 1.4 close it equals. And it's going to spit out a lovely decimal. I'm going to write the whole thing on the board here so you guys can see it first. Because what I found out is another boo-boo that's being made is the rounding. It's not the math, the college math, it's the baby math. So the directions said round to the nearest 10,000ths. Well, here's the decimal point. We got to know place value. That's tenths, that's hundredths, that's thousands, so this is 10,000ths. So 10,000ths always means 4 positions. So the question is, does that stay a 0 or become a 1? Does it stay the same or round up? So the rule is, and I'm going to sing to you a 3rd grade song, underline the digit, look next door. If it's 5 or higher, add 1 more. That's not 5 or higher. So you don't add 1 more. If it's 4 or lower, just ignore. That's 4 and lower, so that means you leave that alone. So when you write this answer down, that's what they want to see. 2.6390. All right, let's try the next one. Okay? I have 5 with the exponent square root of 3. Again, back in the old school, without calculators, you would first have to estimate where the square root of 3 is in between. So I would say to myself, okay, the square root of 3 I don't know. I do know the square root of 1 and the square root of 4. And I know the square root of 1 is 1. So this could be like 5 to the first. I know the square root of 4 is 2. So this would be like 5 squared. And now I have an estimate. This answer is going to be bigger than 5 to the first, which is 5, and smaller than 5 squared, which is 25. So it's important to always, before you touch your calculator, think about what the answer should be. Now let's prove if it's bigger than 5 and less than 25. To type this in the calculator, you type the base, 5, you hit the caret button to tell you're getting an exponent. You always put open parentheses. Then to get the square root button, well, most new calculators have the square root button above the x squared. So here's my x squared button, and above my calculator in blue is written square root. So anything on this calculator that's written in blue, that's why there's a blue button to hit second or shift. So if it's not an actual button to touch, but it's above in a color, that's why you have a second or shift button in the same color. So now I will hit second shift square root. My calculator opens a parentheses to tell what's going to be in the square root, which is 3. Now it's very important when you use your calculators. Every parentheses you open, you must close. So if I close this parentheses, it tells the calculator in the square root is just the number 3. But then I have to close this parentheses to tell the calculator all of this is the exponent. So let me type that in. 5 caret parentheses, second square root, 3 close equals. I get it a lovely decimal. 1.6242458082. The directions say round to the nearest 10,000. How many places? 1, 2, 3, 4. Does it stay at 2 or does it go up to a 3? Underline the digit, look next door. That's 4 or lower, you ignore. So it stays a 2. Okay? So far so good. Let's try another. I want to do 1/6 to the negative 2. All right, we discussed this in 11a. Anytime you have a fraction, it's got to stay in parentheses. So you're going to type, open parentheses, 1 division 6, close parentheses. That shows you're putting in a fraction. Caret to put the exponent. Now we put a parentheses for the exponent, little negative 2. So let's type that in. Open parentheses, 1 division 6, close it. Caret, open parentheses, little negative 2, close it, hit equals. Now that spit out a whole number 36. Do we really need a calculator for that one? No way. We talked about in module 11a. If that exponent's negative, to make it positive, you do the reciprocal of the base. So the reciprocal of 1 over 6 would be 6 over 1, which is 6. And then 6 squared would be 36. All right, our last one. I have 4.9, 4 9/10, and the exponent's 3 pi. Again, I want to estimate. That's a 3. Pi is 3.14, which is closer to 3. So that would be 3 times 3, that's 9. If you took 4 9/10 and did it 9 times, 4.9 times 4.9 and so on and so on. Do you all agree that's going to be a really huge number? Good. So we know by looking at this, we're going to get a really big positive number. All righty, we're going to type it in. Tell me how to type. Type your decimal, 4.9, put your caret, always put parentheses. Now, every calculator has a pi button. You are not to estimate pi to be 3.14. You are to use the pi button on your calculator. So everybody look closely. I actually have a pi button right here. So I would type 3 pi and close it. So I'm going to type that in. 4.9 times, 4.9 caret, open parentheses, 3 pi, and close it. The calculator knows if 3 and pi are side by side, it's connected by multiplication. And here's my really big number. 3198488 decimal point 574. So I put my commas in. That's 3,198,488 and 574 thousandths. It said to go to the 10,000ths, so there's obviously a 0 there. So far, so good? Awesome. Now, I have another new button to show you on the calculator. Let's go back to the notes for a minute. All right, now that we know how to type an exponent in our calculator, let's go here. There's another special number on our calculator, a button that you've never used. It is directly related to pi. It's like pi's cousin. Think about it. Why is pi so special? Is it exactly 3.14? No, it's a decimal that goes on forever and ever with no pattern, no repetition. Well, what happened is another mathematician years later was working on calculations. And what he noticed is the same decimal, 2.718 blah, 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 2.718 blah, 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 kept coming over and over again in his calculation. Well, this mathematician's name was Euler, and his last name starts with the letter E. He was so conceited that he found this number, that he named it after himself, and that's this lowercase e symbol you see on your screen. So the lowercase e is a symbol, just like pi is a symbol. It represents an irrational number, a decimal that goes on forever and ever. Now, on your calculator, that little e is not an actual button. It is above a button. It is above a button that says LN. So everybody go look at your calculator and find a button that says LN. And above it, you will see e to the x. That's your E button. Because it's above in a color, mine's in blue, I would have to hit second in order to get the E to come on the screen. So now we're going to play with the E button. I have 3 examples I want to do on the whiteboard. All right. So if I want the calculator to tell me the answer for E, the value of E, to get E on the screen, there is no E button. It's above LN. So you would hit second LN. And what would appear on your screen is an E and already has a caret symbol. Every time you hit the E button, E is always waiting for an exponent. Now, I know what you're going to say, Miss Black, I don't see an exponent. Everything that's a number has an exponent. It's understood to be a 1. So you'll have an open parentheses and type a 1. Because if the caret goes up there, you got to put a parentheses. So you will hit again, second LN. It will put the E with the caret symbol on your screen. Then you'll type in the exponent 1. You'll close it, hit equals. And you'll get out an irrational number, a decimal that goes on forever and ever. Because this is a typing exercise, our directions, I'm looking at them, say to round. We're going to round 4 places. So we have 2.718281828 to the nearest 10,000th. 1, 2, 3, 4. Underline the digit. Look next door. If it's 5 or higher, add 1 more. So because behind the 2 is an 8, this rounds up to 3. So we would say this answer is 2.7183. And we're allowed to round because it's just typing. We're not finding the exact answer. All right, so to type in E squared, how are we going to do it? To get E, we're going to hit second or shift LN. E is waiting for its exponent. Well, we see its exponent. It's a 2 here. So open parentheses 2 and then close it. Hit equals and you get a lovely decimal. 7.389056099. We're rounding to the nearest 10,000. 1, 2, 3, 4 positions. Underline the digit, look next door. If it's 5 or higher, add 1 more. It's a 5, so if we add 1 to 0, we get a 1. So this will round to 7.3891. Now, this is important. I wanted everybody to get a good calculator that works forwards, because the way you read something is the way you type it. If you have an old backwards calculator, the way you read it is not the way you type it. So if I asked you to read this expression, 4 to the E, what did you say first? Did you say the 4 or did you say the E? You said the 4 first, so that's what you have to type first. Don't hit the E button yet. What you read is what you type. So I have a 4. So I type 4 on my calculator. Now, I've got to be smarter than the calculator. I'm the operator. This E is in the exponent spot. How do we tell the calculator we're putting in an exponent? Good. We hit the caret button. And Ms. Black told you, every time you hit the caret button, you're going to put an open parentheses. Now, what is the exponent? It's E. So to type E, we hit second ln. But wait a minute. When we type that on the screen, it puts another caret. It's waiting for another exponent. So we look at E. What's its invisible exponent? 1. I have 2 parentheses opened, so that means I got to close 2. So it's very important you have the right kind of calculator that types forwards. 4 caret. E has a caret. So you type its exponent 1, you close the parentheses, you hit equals. You get a lovely decimal, 43.30806043. If you're getting a couple of more numbers than me, a couple more digits, it's okay. Every calculator screen holds a certain amount. We got to go 4 place values, 1, 2, 3, 4 to the nearest 10,000. Underline a digit, look next door. If it's 5 or higher, add 1 more. That's a 6, so we add 1 more to 0, it becomes a 1. So this would round to 43 and 3,081 10,000s. Everybody with me? So far, so good? Okay. Now, there's a purpose for this. Let's go back to our notes and see why we had to learn how to use our calculators. Okay. In our notes, here's the purpose. We are going to be working with formulas. Formulas are already equations set up that show a relationship. I know you've all worked with formulas in your everyday life and in your math. You've all know the formula for area, or for perimeter, or for to find volume, or to do Pythagorean theorem. Today's formulas are related to you. They're related to money, banking, and they're related to the concept of interest. Now, we all know in real life there's good interest and bad interest. The bad interest we don't want to talk about. I don't want to talk about the interest you pay on your credit cards or your mortgage or your car loan or your student loans. I want to talk about your good interest, the interest you get on your savings account or your retirement account or an annuity. So we're going to talk about interest. I stands for interest in math. To order to collect interest, you first have to invest money. That's called principal. So principal is always the amount you invest. Okay? There's 2 ways you can get interest. There's simple interest and there's compounded interest. So now I expect you all to go look at your savings accounts and see which kind of interest you're getting. Simple interest is only given 1 time a year. Compound interest is given several times a year. You can get compound interest twice a year, which would be semi-annually. You can get it 4 times a year, quarterly. You can get it monthly, 12 times a year. You can even get it daily, 365 days a year. So what we're going to talk about is how to figure out that interest. So if you look, we have formulas. Now, no one expects you guys to memorize these formulas because in the real world, you look formulas up. We have 3 formulas here dealing with interest. The one on the top, I equals P RT, is for simple interest. If you got interest once a year. Okay? And what would happen is you would take your principal, how much money you have, You would times it by your interest rate, and then you would times it by the time, how long it sits in the bank. If you got compounded interest, the formula is a little bit more complicated. It's A equals P, 1 plus R to the N to the NT. Now, the first thing I want you to notice is that's an exponential equation. There are two variables, N and T, in the exponent spot. So that's why it fits into this chapter. What I want you to notice about that formula, it has the same three variables as simple interest. P is principal, how much money you're going to put in, invest. R is your interest rate. T is how long time it's going to sit in the bank. The N here represents how many times the bank's going to give you interest. Whether they're going to give it 2 times a year, 4 times a year, 12 times a year. In the ideal world, and I do talk about the ideal world utopia, you would get interest every moment your money sat in the bank. And that way you could put no number on that. If you collected interest every moment you sat in the bank, you could not put a value on N because N would go to infinity. So that's why there's a third formula. A equals P-E-R-T. Again, look at that formula. It still has P for principal, how much money you're going to invest. It has R, the interest rate. It has the time. What it has different is that special irrational number E. And you're going to find out when you go on to your other careers, in your other classes, you may see more and more formulas dealing with E. Now, please, before we even get going, do not go to your bank and ask for continuous interest. Nobody gets that. That would be the ideal situation. So what I want to finish with today is this problem. Let's pretend we won $10,000. And we're going to be good and go invest it in the bank. And right now, the bank's interest rates are not very good. Right now, on a savings account, you're getting a little bit more than 1%. So I have 1.8% here we're going to get. And I'm going to invest this for 4 years. And I want to figure out all the different amount of monies I can make depending on what kind of interest I'm going to earn. So yes, we're going to need our calculator, and yes, we're going to need those formulas. So let's go to the whiteboard, go get your calculators, and let's go do some work. So the first question A said simple interest. So you're going to write your formula. I equals P R T. You're going to fill it in. I is interest. I don't know that. The principal, we're investing $10,000. The interest rate was 1.8%. Now here's the problem. That's a percent. You can't work with a percent. A percent is a way to represent something of 100. So you learned back in 5th and 6th grade, you never work with a percent. You change a percent either to a decimal or a fraction. In this case, because we're dealing with money, yes, you want to change it to a decimal. Now, I know what you're going to say to me, but Miss Black, there's already a decimal point in it. Isn't it a decimal? No. Think about this. If I said the tax is 8%, that's a whole number 8. How do you change that to a decimal? You move the point 2 places to the left. So if you look at your Walmart or Kroger's or whatever receipt, and they say there's 8% tails tax, that's written as decimal point 08. So if I give you a percent, I don't care if it has a decimal point in it, you have to change it to a decimal by moving the point 2 places to the left. Why do you move the decimal point 2 places to the left? It is because percent is out of 100, and we're dividing this by 100. So 1.8%, if we move the decimal point 2 places to the left, would be the decimal 0.18. And that's what's going to go in your formula. And our time was 4 years. I know that's simple arithmetic, but we're not going to make you multiply that out. That's what the calculator's for. So we'll type in 10,000 times 0.018 times 4, and it says $720. So if we invested $10,000 at simple interest, at the end of 4 years, our interest would be $720. We would end up with a new amount of $10,720. Okay? That is obviously not the best way to get interest. We're all about making lots of money. So now let's look at part B. Part B says find your interest semi-annually. Semi-annually means the bank's going to give you interest twice a year. That's this formula. So for Part B, we know our principal is still $10,000. We're going to write 1 plus. Our interest rate is still the 1.8%, which is a decimal, 0.018. But now we're going to divide that 2 times because it's semi-annually. Just so y'all know, when the bank says they're giving you an APR, an annual interest rate of 1.8%, that means in the end of the year you will make that much interest. That doesn't mean every time they give you interest you're getting 1.8%. That's why we're dividing it by 2. The N again is 2, and our time was 4 years. So A is going to represent our new amount. Now, when we work this formula, we need a calculator. The reason why I wanted a good calculator is you type what you see. So when I go to type this in the calculator, I'm going to type exactly what I see. 10,000, open parentheses, 1 plus, decimal point, 0.018, divided by 2, close parentheses. And now here comes the problem. You have to be smarter than the calculator. The next thing going is an exponent. So you got to hit the caret button. I've told you once, I've told you 100 times now in this module, when you hit the caret button, you must put open parentheses. Because you want to tell the calculator in the exponent spot is a 2 and a 4. And that's 2 times 4. Now I know you can multiply that in your head, but what happens if these exponents get really big? So don't do the work, just type it in. So what I've written here is what you should see in your calculator screen. We're going to hit enter, and we're going to get 10,743.09287. Now, did the directions say it around? No, they did not. But here's where you got to think. This is a real-life word problem. We're dealing with money. What is the bank going to round it to? That's right, they're going to round it to the nearest penny. So I don't have to tell you to round it. You're supposed to know that because it's a real-life problem. So the nearest penny, we have 9 cents. Would it stay 9 or would it go up to 10? It would stay 9. So if we got interest twice a year, we would now make $10,743.09, which is more than simple interest. So now let's go to part C. They want us to get our interest quarterly. Quarterly means N would change to 4. So to do part C, all we got to do is change one number in this formula. 10,000 is going to stay. The 0.18%. The time is 4. What's going to happen now here is N is going to become 4. So, the third part, we'd write N is 4. So again, it's a typing exercise. You type what you see. 10,000, open parentheses, 1 plus, decimal point 0.018, division 4, close parentheses. Uh-oh, now an exponent's coming. I got to put a caret. I got to open a parentheses. What's in the exponent spot? 4 times 4. So I'm going to type that in. Type along with me. Did you get $10,744.81784? Now, because it's money, what did we say we round to? Good, the nearest penny. That penny is a 1. Does it stay a 1? Nope, behind it's a 7. So that means the bank would have given me, if I got interest 4 times a year, $10,744.82. Did you make more money if you get interest 4 times a year? Heck yeah, a little bit more. Let's now say if we got interest monthly. Again, what's going to change if we get interest monthly? The N value. It's not going to be 4. What's it going to be? It's going to be 12 now. So we're going to replace N with 12. And up here, I'm going to replace N with 12. So for part D, I should have A equals 10,000. 1 plus decimal point 018 divided by 12 times to the exponent 12 times 4. So what I read is what I type in my calculator. So I'm going to type, let's do it together, 10,000, open parentheses, 1 plus decimal point 018 divide by 12, close parentheses, hit the caret, open parentheses, 12 times 4, close it, hit equals. Okay, I get now $10,745. And we know it's money, so we know we're going to round it to the nearest penny. I see 97 cents with a 3 behind it, so it's going to say 97 cents. Is everybody good? Good. The last one, again, you can't go to the bank and ask for this. You can't get continuous interest. It doesn't exist. It's the utopia, the ideal situation. If you're going to get continuous interest, that's every stinking moment your money sits in the bank. So you can't put a number on that. That's why this formula won't work. So our last formula, which I call PERT, P-E-R-T, is our formula to get interest continuously. So for part E, A equals, our principal is still 10,000. The E you leave in. E is not a variable. E is like pi. It's a symbol that represents an irrational number. So we leave the E. The interest rate is still decimal point 018. And we're going to multiply that to the time, 4 years. So now we got to type that in. So we type 10,000. Who remembers? How do we get the E on the screen? Very good. We hit second ln. That puts the E on the screen. As soon as the E goes on the screen, there goes a caret with a parentheses. Because the calculator knows every time you hit E, you want its exponent. So it already put the parentheses. So all I got to type is 0.018 times 4 and close it. And hit equals. And if I got interest continuously, I would make $10,746. I see 55 cents with a 3 behind it. So the 3 means it would stay the same, 55 cents. So what I want you to notice is, depending on what kind of interest you're getting, depends on how much money you're going to make. And what I want you to really appreciate is this formula and this formula, which are equations because they have equal signs. Both have variables in the exponent spot. That's what they mean by an exponential equation. So we just saw in real life where you would use an exponential equation. Okay, we have a new equation to meet in Module 12. See you then.